What up YouTube, this is Banjo3Fan3 here, making another physics video, because the first one was obviously just a basic one, this one's going to be more in detailed. Alright, so this unit is changing motion, and it's just kinematics. If you don't understand what kinematics is, it's just pretty much moving from one place to another. It's very simple. It's displacement, where you are at, how fast you're going, and if you're accelerating or not. Anyway, if you didn't watch my first video, one thing that can really help you is the freaking formula sheet. I cannot emphasize this enough. Look at the formula sheet. The formula sheet has everything on it. And if you don't have the same formula sheet as me, I'm willing to make you a copy of this formula sheet so you do not fail. Anyway, there's this whole section on kinematics that can help you, such as these, if you can see them. That's really bad focus, actually. So I'm just going to say them out loud. X is equal to x naught plus... Oh my god. Okay, I'm sorry. This is sounding a little complicated. Let me just put it this way. Distance is equal to speed, velocity times time. It's easy as that. That's x is equal to x naught plus v average times t. Which... okay, don't think of variables. Alright, variables can be replaced with anything. For x naught, you could put I. It doesn't even matter. Just you have to understand the concept behind them. What does x equal? What does v equal? What does t equal? T is time, v is velocity, x is displacement in the x direction. Don't think of it too hard. I mean, if you have to draw a picture, I mean, pictures are probably your best tools. It'll help you a lot. Anyway, there's also v is equal to v naught plus at, which means pretty much your acceleration or your change in velocity is equal to acceleration times time. And then there's your displacement, which is change in x, is equal to v naught times time plus 1/2 at squared. What does this mean? It means your change in displacement, the change you move, is equal to your initial velocity times the time you're going there, which should be constant, and your acceleration times time, if acceleration was constant. So, let's say you're going this way at a velocity of, let's say, 5, alright? And then you're accelerating this way, right? You're going this way, you're accelerating this way. If you're facing the opposite direction, it's called deceleration, and you should end up going to 0 velocity. You should have a point where you go and then back. Alright? But if they're going the same way, then it'll end up accelerating you, making you go faster. And if it's perpendicular, this is the acceleration, this is the velocity. As long as it continues being perpendicular, it'll make you go in a centrifugal force, which makes you go in a circle. I'll discuss that more later, but just understand that if you draw a picture of which way your acceleration works and stuff, you'll figure out easily. Now, there's also v squared is equal to v naught squared plus 2a change in x. This one's a little more complicated to explain. I'm just going to say manipulate the equations you had earlier. You'll figure out this way. Other than that, there's no other way to clearly explain how to do this one. There's also the change of velocity of x is equal to the initial velocity times cosine. And there's also velocity in y direction is equal to the initial velocity times the sine of theta degree. Pretty much just draw a picture for that. It's a triangle. It's not too complicated. If you know your trig functions, you'll be fine. Yeah, just know your trig. And that's pretty much all the equations for kinematics. Things you can do is make a chart of this. Alright? I don't have a dry erase board at the moment. I think my brother does. I'm gonna go kidnap it. One moment, please. Oh, fuck. Alright, so I'm having a hard time finding his little board, but I found his marker, so let's keep looking. Sorry again. Ah, dang it. Alright, so I wasn't able to find this board. FML. I just wasted my time and I made you look at the screen for nothing. So I'm just going to get a marker and draw this out on a sheet of paper. Got a few sheets of paper. Okay. So first thing you want to do is understand what it's asking for, alright? So they give you an equation. X is equal to x naught plus V A V G, V average, times time. Alright, so what does this mean? Change of x. Wait 1 second, this is a little easier to understand. Alright, change of x is equal to the average velocity times time. Now, why would you use this equation if you don't have acceleration? So, if you don't know acceleration whatsoever, all right, but you know the rest of these, you can figure out for another variable. Now, the next equation is velocity is equal to initial velocity plus acceleration times time, or the change in velocity is equal to acceleration times time. Alright, why would you use this? If you don't know your displacement whatsoever. So, change of x, you don't know what change of x is. And change of x is equal to x minus x naught. By the way, if you don't know what the word naught means that I'm explaining, x naught is pretty much just the initial x. Alright, that's where you start. Now, the next one that you will probably want to consider is v squared is equal to v naught squared plus 2a change of x. Or let's write this out. V squared is equal to v naught squared plus 2a x minus x naught. And why would you use this? Why would you use this equation right here? Is if you don't know what time is. Alright? If you don't know what time is, just use that equation and you'll be fine. Now the next one. Actually, that's all of them that you actually that you could actually use. There are 3 other ones, but 2 of them are trig functions, and the other one I'll show you why I'm showing you this one last. X is equal to x naught plus velocity times time plus 1/2 acceleration times time squared. Or the change of x is equal to your velocity times time plus 1/2 acceleration times time squared. Now, why would you use this huge ass motherfucking equation? Alright? Well, if you notice, you get these equations, right? You get all these, and it's missing acceleration, it's missing change of x, it's missing time. So how do you put them all together? That huge equation. And with this huge equation right here, this is if they give you all the information. This is your last resort, I would say, your last resort. This one only works if you have velocity's average. If you don't have the average, then you can't use this one. If you don't have any one of these, you can't use it. And most likely it's going to be a velocity average that you don't have. For this one, if you don't have one of the characteristics, most likely it's going to be your ending velocity that you don't have. Then you'll use this equation down here. In this one, also your initial velocity, if you don't have that, you'll use this one down here. So the one on the bottom is usually the broadest one. It has the most choices, but it's usually the one that's missing something. So watch out for that. Also, do not get confused because I'm using the term x. You can replace this with y. X just means horizontal distance. If it says y, it means vertical distance. X is horizontal, B is it's just like a graph. As easy as a graph. And so let's go through an equation or a problem that's written in here. Let's start with an easy one. Actually, I don't think I can find one right now because it's so clumped. I'm just gonna go to the sketches because I don't have time to do problems, but I can go over the main concepts. Now, if you guys did this, it's the graphs of the time versus position, time versus velocity, and time versus acceleration of when a block went up and down a ramp or whatever. How do you know when the acceleration is positive and when the acceleration is negative? When the velocity is positive, velocity is negative. When displacement is positive or negative. Well, honestly, you will never have a time where on these graphs at least, on these graphs, you'll never have a time when your displacement, change of x, or position, is negative. Because it is impossible to record with a recording device a negative position because it only looks one way. Like, here's the thing. Beep, 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 beep. Anything behind here is like, what the hell's going on? So, usually the graph will look like this. Position versus time. Now, how do you determine where it's going to be on the graph? Just draw it. I mean, pictures say 1,000 words, supposedly, but you I don't know, this is a corny line. I don't like corny lines, but hey, it helps. Anyway, so position, just to find out where it is, it's how you really need the other stuff to go with it, but for this situation, I'll just say we don't have any other information. We're just trying to find the x. So here's your particle, right? And here is where it starts at. This is the 0 point, all right? And here is the maximum, whatever you want. Alright, if it's going to speed up this way, it's going to curve. If it goes at a constant speed, it's just going to be a line. Oh, sorry, it's going to be a line that way. Sorry, this way, a line. Line this way. And, that was just a horrible description. I'm so sorry about that. All I can say is, actually, I'll go into more detail to that a little bit later. You'll see what I mean in a second. Now, the velocity one is a little trickier. Not as tricky as the acceleration, I would say, but it's a little tricky. The velocity graph will sometimes look like that. I will not say it always looks like this. There are times when the velocity graph looks like this. where it has a positive and a negative onto it. Why will it have that? Because speed is always positive, but velocity depends on direction. Velocity is speed with a direction, which will end up giving you a displacement in the end. So, what does this mean to you at all? Well, they cannot ask you what is the velocity without giving you direction. Let's say this section is positive and this section is negative. All right. So when you are going from positive to negative, that is a negative slope. When you're going from negative to positive, that's a positive. It's just like a graph. All right. So let's say you're going from the original place to a positive place. It has to say on there positive. Ta-da, positive graph right there. When you go into a negative place, negative. I'll get into more detail about how to graph those a little bit later. Let's go to acceleration. Now, acceleration has graphs just like velocity. It can either be the normal way, where you saw it with position, or it can be, oh, I just totally messed up that graph. Okay, the next graph, the acceleration is going to look huge, but kind of messed up. Alright. It'll either look like this or this, alright? And acceleration it usually does not change, but sometimes it can due to friction and other external forces. But most of the time it would be the same direction. It's usually going to be a constant, and it's usually just a straight line across the thing. So usually you will see and also acceleration does depend on location. I'm going to say that now. Acceleration and velocity depend on direction. All right. So here's the thing, right? Positive, negative. All right. If you are going toward the negative direction, all right, at a constant speed, that means your acceleration is 0. But if you started out at 0 velocity and ended up speeding up toward the negative, that means you're having a negative acceleration because you're going to the negative section. And also, same vice versa. Bam. How does this come into play? Well, here is a situation, right? Let's try to get it into the screen. You have a graph going like this, right? You see it's a curve, or hopefully you can see it's a curve. My screen's lagging. You see, anyway, so what you have to do with that is find your accelerations. I'm getting a little bit into derivatives, but it will help you. Alright? So, first thing you have to decide, are you going toward or away from the starting position? If you're going away from the starting position, then your graph will look usually like that. If you are going toward the starting position, your graph will usually look like that because of gravity. Gravity accelerates you. Now, if this is your case, right, just find the slope of it at one point. You can see that you just draw a line tangent to the curve, alright? Make it so that it touches one point of the graph. And you can find out that it's a negative slope. Over here, find one point that touches. Right there. I don't know if you can see that really well. I'm going to bold it out. Right there. And that shows that it's a positive slope, which means your acceleration is going to be positive. And from these, like watch, like you see this one right here? Bang. Velocity right there. This one going positive, it's going to end up as this positive one. Alright? Simple enough. Now, for the velocity, you're going to have to do a more of a, see if it's a curving thing. If it's a curving thing, then you're just do the same thing you did for this one and for your acceleration. Alright? But if it's just a straight line, see which way the line's going. Is it going positive up or negative down? Alright? Once you find that out, it's as simple as drawing a straight line on the positive section or a negative line on the negative section. And with that, you can go backwards, but that's a little more complicated, and I don't want to go into that because I will bug you with plus C, and most of the calculus kids will be like, oh, you shouldn't teach them plus C because it's so complicated. And the physics kids will be like, oh my gosh, you're teaching us plus C, and I'll just be like, I'm sorry, I'm trying to help. Anyway, let's see what else is in this packet that I can help you with. Mostly this seems like the graphs. Alright, I think that's it for changing motion. To recap the whole thing, look at your equation sheet. That will really help. Understand the equation sheet. That will help even more. And for the graphs, just draw lines. Lines can be your best friend. Alright? Also, last and probably one of the most important things for understanding velocity and acceleration, direction and possibly magnitude. Magnitude is just how much it is. Alright? Anyway, this is Banjo-Kazooie-Fan3 here, saying I hope you understood that. Sorry, it's my first time making a tutorial video, and we'll see how this goes. Bye!